So sorry about that. We were working out the series separately, and I'm just going to continue straight with that. Not sure what happened. The computer just disconnected for some weird, very weird reason. Anyways, we continue, we soldier on. So someone had picked that there is a sequence when we look at the whole numbers only and the fractions only. So someone had picked that, which is excellent, and that's exactly what we want and get to appreciate here. When you can see things from that view, it's always good. So let us quickly take note of that and then run with this sum. So I've got 1. So I've got 1, and then I've got 5. I've got a 9 and a 13. So this was my first sequence. So maybe let me just have them side by side. So 1, 5, 9, 13, and then I've got a half. Then I've got a half, a fourth, an eighth, 16. Now, there's a clear picture. We can actually predict what's happening here. For example, there is a constant difference right away of a 4. So here, no debate. If we're going to find the general term here, in fact, if we're going to go find the sum, we are finding S20. Oh, by the way, the question there was requiring us to find the sum of the first 20 terms. And my bad, we're going to find S10 actually. Because what is happening, I hope you see this, think about it. Half of the arithmetic terms make up the sum of the 20. So half of 20 is 10. And then half of the geometric will make up half of the 20. So the geometric, we're also looking at 10. And again, I mean, you can do a quick test here and do your divisions. You realize that, I mean, if you can do quick math, 1/4 divided by 1/2, you realize you're going to get a half there, right? So what is happening each time here, you are multiplying by a half to get the next term. So we can clearly see here that the constant ratio is a half. So here R is a half, and guess what? A, the first term, is also a half. On the other hand, the constant difference is a 4. Let's maybe take note of this because these are the parameters you need for your summation formulas. So A is a 1, the first term, the constant difference is a 4, and then on the other hand, R in the constant ratio is a half, and the first term happens to be equivalent to R. So we look for S10 here. We don't have the last term, but at least we know we are finding 10 terms. So N is not an issue. Remember, it's going to be N/2, so I'm doing the direct substitution right away. 2 times 1 plus N minus 1. If you think about it, you can write the 9, or you can just write the 10 minus 1 times 4. And you do some calculator work here. And then the next one to do that will be for the geometric. Last week, we learned about the geometric series, and in that geometric series from last week, we found the formula. In fact, we did the sum to infinity for a geometric series as well. So if you'll remember here now, S10 will be equal to, it said A times, well done, thank you. I like the fact that you guys are working with me here. So someone has already calculated that. A times R to the N, we had something like this, and N here is 10 minus 1, and this is all over what? R minus a 1. So again, if someone will do this on the calculator, we got a 190 here. I see the answer of 190. That's excellent. And then the next one, who's doing this one of S10? Let's check. I'll be checking the chats there again. It will be great if I get responses. Okay, I'll wait for S10. But the point is, if you're going to get S20, Then you're going to combine the two sums. So you're going to take the 190 and add whatever answer you're going to get here. You're going to add it here. So that's your calculator work. I leave that up to you. This is how you're going to do it. So this is the worst possible scenario, but as you can see, it's not really a worst case scenario. It is one of the easiest things because you just have to break down this complicated series which is not matching what you know. Okay, so that's very important. I hope you've taken note of that. Another extraordinary question, by the way, which I would like to tackle. Remember, today we're just tackling a bit extraordinary out of the box questions. So that's one. There's another type. So, oh yes, someone got this for me. Well done. So we have a 1023 over 1024. Good. And that's an affirmation that you are well versed with using your calculators. So your job then is to just add the 190 to the 1023 over 1024. So that's not an 11, please. It's 1000, and so it's 1024. So you can add that, and then that will give you the summation. So sometimes you actually get yes, correct, 190.990. Now, because they set to 4 decimal places, even though we may get that 000, we must put a 0 as a placeholder to follow the instruction. They can easily penalize you, and I'm sure you don't want to lose 1 mark for an error on rounding. Okay, so very key to note that. Well done, guys. I'm glad you are catching this. Okay, now I guess if I've given you this, you can follow another instance, and I would want you to try this on your own. You gotta try this one, but you will try it when we are done with the lesson. So I just want you to take note of this one. So if you have understood, or to check whether you understood what I've been doing here, here is another series. Again, we are calculating the sum. So 3 plus 2 plus 9 plus a 2 plus a 15 plus a 2 and then 21 to watch here 597. So if you notice here, they are not telling you how many terms there are in this series. And this is the part where I'm going to check whether you paid attention in the previous lessons. It is clear in the previous videos. I told you what to do in the situation. In other words, how to figure out the total number of terms. So I'll leave that up to you, but try this. The question is simple. Calculate the sum. So that is for your homework to try and do, and you are welcome to drop me a direct message so that I check whether your solution is correct or not. Another extraordinary question that is often asked, a little bit out of context, or in terms of other series and all that, is this one. Look at this one. They say calculate the sum. Oops, not sure what happened here now. Oh, Asi has taken over my whiteboard, and I know it was not intentional. So let's help Asi. Okay. So calculate the, was writing right here. Oh, okay. And Amanda saying they couldn't see the last question. Okay, there's the last question. Maybe let me give you a few seconds to copy that down. Okay, sure, no problem. Let me allow you to copy that down. So the easiest way to do this is to take a screenshot, right? So you can try that. Okay, going once, twice, thrice. It's gone now, hey. Yeah, you've taken your screenshot. Right. So let's look at the second question. I mean, the other unusual question that we often do not receive. So this one, this is what it says, or this is how it is phrased. So calculate the sum is this pen working? Okay, undo there. Or maybe I should just type. Let's clear the page. And let's type this one. That will make it quicker, I hope. The sum of the first n terms of, now Frank is taking over. Okay, guys, just try and avoid being on this. If it doesn't appear on the thing, it's fine. I will post this in the WhatsApp group, okay? So don't panic if you don't have this. Just don't panic, don't worry, don't stress. You're gonna get it. The sum of the first n terms of a series is given by some formula, and I'm gonna show you this formula. I'm gonna show you this formula. The formula reads Sn I hope there's no one trying to compete with me for control on the board here. So here's the formula. Sn is equal to 2n squared plus 4n. So we know in sequences and series, right, that Sn represents the summation. Okay. So the first question requires us to calculate the sum of the first 200 terms. That's not an issue at all. The interesting question is this one. Calculate the value. Okay, gonna try and control this now. Now it was linked. I'm not sure. I think using Zoom board was a mistake today, but it's fine. We'll sort it out in the next one. We'll go back to using the normal board I use, because this one, it's confusing. So calculate the, don't try and use the board to answer the questions. I think that is what is happening. Calculate the value of the 100th term in the series. See, so this is a very, very interesting one, because then you'll be like, am I supposed to write out the series and then all of a sudden find the value of the 100th term? Impossible, examiner. How can I do that? Now, here's the formula, right? Whenever you are given a sum or an expression for the sum, and you are asked this type of a question, the simplest way to go about it is to do the following. And this has to make sense. I'll show you. If it doesn't make sense, I will show you. This is the formula. Tn is equal to Sn minus Sn minus 1. Now, for this to make sense, think of it this way. Remember, I don't like it when I just throw formulas at you, although sometimes time forces me to just do it. So I'm sure you know what is happening on this series, right? Now, I want you to think of term number 2 here. I need you to get the concept. Think of term number 2. Let's say I want to know, I would really like to know what term number 2 is. What this formula is saying is, to find term number 2, you need to notice the following. You need to notice the following. So try and log out and come back in again if you can't see anything. Okay. Now, S3, I want you to see what's happening, because what this formula is doing is, if we want term number 2, we must go S2 minus, watch this now, S1. This is what the formula is saying. So in other words, if I want term number 2 here in green, I must also look for the sum. I must first look out for the sum. Okay, I hope you can see now. Sorry about that. I hope you can see. I've tried to do something to help you see here. Okay. So if I want the sum, or term 2, consent. I would like to, it would be really great if you really get where this formula is coming from. But this is where it actually comes from. So in this case, that's actually what we're going to do. If we want term 100 here to answer the question now, to answer this question, if we want term number 100, I must say T100 is equal to, check this, surely it must be S100 minus S99. How do you find S100? You substitute 100 into that formula. How do you find S99? You do the exact same thing. You substitute 99 into that formula. So these are the two key things that I need you to gather today. And there's actually many other things, but obviously with those many other things, there's gonna be what? We're gonna require a lot of time for that. So what I will do again, what I will do, and listen to me attentively now, what I will do is that on a Tuesday this week, I'm gonna kind of present or record questions which would have been brought by you. What I would like you to do is on WhatsApp, send me questions on sequences and series. Send me those questions, and these are, I hope, will be questions that are usually unseen and all that. Or you can go to the booklet that I have shared in the WhatsApp group, and in that booklet, not if actually. I will just come and present those questions and say, okay, so here's one of the questions I received, and this is my thinking, or this is my proposed solution towards that question. That's what we're going to do on Tuesday. That session will we will look at the next chapter, and I'll tell you what that chapter is. We will look at the ATP that has been circulated. I suspect we will go straight into functions and inverse functions. If not, who knows, we might as well even do calculus, but it won't make sense to do calculus having not covered functions. So that's going to be it, all right? As I got to rush for another 6 p.m. appointment, so let's stop it here for today. But as I said, my expectation from you is the following. Try this question. When you have tried this, go to the document, look out for questions that are challenging to you on sequences and series, and we will tackle those questions and close off this chapter. I need you to be in a position where you can solve literally every single question on sequences and series which you come across. That will tell me that you are indeed ready for your trial exam and your final exam. Okay, that's about it. I'll see you guys on the WhatsApp group. Cheers.